This is the third stage of the video that presents the example model for SlopeX. So this is how the interface looks when you start. You have 5 main parts on the left here. I'm going to start with the settings. As I've mentioned in the previous video, I've chosen to import STL format files. You can bring in DXF if you wish instead. I should probably note actually here straight away that there's a help all the way through, so you can click on the help buttons wherever you wish. I've chosen the example model folder that I've created on my C drive where all my files are located and my license file. Here you can opt to include model outputs. These generate CSVs during the model run, which you can then import into a viewer. That's discussed in the last stage of the video. Okay, so I'm going to leave that, turn it off for a minute. Down here we have the strength reduction controls, which are obviously used to which allow you to resolve the factor of safety. So here I have a maximum strength reduction factor of 2 and a going in increments of 0.2. Over here we have the model mesh controls. So you can opt to include a model mesh. This can come from another meshing package, or even another FLAC3D file that you wish to group using SlopeX. In this case, we're going to generate the mesh. So I've entered a target number of zones in the model. This is quite important because you can essentially use it as a limit. So if you are, say, running on a laptop where you don't have much RAM, you may want a smaller number in there. I've entered a boundary offset of 500 meters, which is sufficient from the excavation stages in this case. And down here we have the failure criteria. Now this allows you to set thresholds which are essentially used during the plotting, and it allows you to interpret the instability in much in the same way that you would interpret data from, say, a prism or radar monitoring. Okay, let's move on to the next part.